If there are no questions on any of the assignments so far, we're going to go on and get started with today's lesson. Now, today's lesson, what we're covering today, is going to be helpful, especially once we start solving these equations here. Yep, so it'll be 2 sheets. Yep. Now, the first part is the fact that these are inverses. The exponential function and the logarithmic functions are inverses of each other. So if we take log base b of b to the x, so if the base and what's inside the logarithm are the same, they simplify out, giving us with just whatever the exponent is. So for this here, it's just going to be x. Now, if we have b to the log base b, so the base and what's the base of the logarithm are the same, they will cancel out as well. And we did some of this on Wednesday when we talked about, say, log base 7 of 49. This is one of the problems from the homework assignment. And when we looked at this here, we said equals y. So we're trying to see 7 to the y equals 49 if we rewrote it back in exponential form, which would exactly be 2. Because 7 squared is 49. Now, what this property is saying is if we rewrote this as log base 7 of 7 squared, because 49 is 7 squared. Now, since the base and what's inside the logarithm are the same, this right here will actually simplify out, leaving us with just 2. So if the base and what's inside the logarithm are the same, they cancel each other out. So, and it works the other way too. So here we have 10 to the log of 4. Now, anytime the base is not written with logarithms, it's understood to be 10. So log of 4 is the same as log base 10 of 4. So log base 10 of x is the same as log of x. It's the same with the natural log of e is the same as ln of x. If for logarithms, if the base is 10, we don't have to write it in. With natural logs, if the base is e, we don't have to write it in. Now, looking at this one here, these two here are the exact same, yes? So this simplifies out, leaving us with just 4. Questions on this here? This is kind of a funky property, but it's very nice that it does work the way that it does. Any questions on any of this here so far? If there's no questions on A, let's look at B. Now, B says that I have log base 5 of 25 to the x. Now, what would be nice is if I could rewrite 25 as a 5 to a power, because log base 5 of 5 would simplify to 1. So how can we rewrite 25? 5 squared. Now, to simplify those parentheses, we can rewrite this as log base 5 of 5 to the 2x, because powers of powers multiply, so our 2 times x would give us 2x. Now, log base 5 of 5, this here would simplify to 1, leaving us with just 2x. Any questions on this here? Do we kind of like this property? And we'll be utilizing this here when we start solving. Let's look at this next one here. 10 to the log of 18 would simplify to what? 18. Because even though it's not written the base for this log is 10. So we have 10 to the log base 10 of 18. And again, these here undo each other. They cancel each other out. Any questions on A before we look at B? Now, looking at B, we have log base 4. So it'd be nice to be able to rewrite 16 as 4 to a power. 4 squared. And we could just say this is at 4 to the 2x, because our square with 4 and the x would multiply together, giving us 2x. Yes, and then this would simplify to 2x, because whenever the base and what's inside the logarithm are the same, it simplifies to 1. Any questions on this here? Let's look at 4 more. Let's look at these. Yes, 8 to the log base 8 of x would simplify to just x, because the 8 to the log base 8 simplifies out. Yes, because log base 7 of 7 simplifies to 1. Now, here, 2 and 64 are not the same. But we need to see if we can rewrite 64 as 2 to a power. So we can see here, so we could say 2 to the 4th is 16. So if I multiply it by 2, so 2 to the 5th would be, one more would give us 6 2s, which is 64. So we can say 2 to the 6 is 64. We could go by dividing by 2. So if we took 64 and divided it by 2 and see how many times it takes for us to hit 1, because if we keep dividing, we'll eventually hit 1, we would divide it 6 times. So what we can say is that 64 is the same as 2 to the 6, and then we have our x. Now, here we don't have to do the parentheses around it because we only have one term on the outside. If it had been, say, 64 to the x plus 1, we would have had to multiply the x plus 1 by 6 because of the parentheses and what the power is 2. But since it's just x, we can just say it's 6x. And what would this reduce to? 6x. And lastly, e to the ln of 20. What is the base for e, or natural logs? I just said it. It's e. So here, it's not written, but the base is understood to be e. So we have e to the ln base e of 20. What we were putting it to and what the base of the natural log are the same, yes? So those will simplify out, leaving us with 20. And there's a reason that these simplify out, and it's easier to show with, let's say ln base e of e equals y. Well, if we rewrote this as exponential as we worked with last week, we would say that we have e to the y is equal to e. What's the only power I can use that gives me back what I already put in? The only way value that y can be is 1, because e to the first is still e. If we did it with log, so log base 9 of 9 equals y, we would say 9 to the y is equal to 9. The only value that y can be is 1. Whenever the base and what's inside it are the same, it simplifies to 1. Any questions on any of this here? All right. The last thing we're doing today is finding the inverse. Now, it does work out that our exponential function and our logarithmic functions are inverses of each other. So if we look at f of x equals 6x, to find its inverse, the first thing we'll need to do is rewrite f of x as y. That's our first step in writing an inverse function. The second step that when we do this here, we need to switch x and y. So x is equal to 6 to the y. And to get the inverse, we're just going to apply or switch it from exponential to logarithmic. So if I rewrote this as a logarithmic function, what would we have? So we'd have log what? Base 6 of x is equal to, because this is going off the fact that y equals b to the x if and only if log base b of y is equal to x. And on the inverse, we are switching x and y. So that's why the y and x are flipped when we're looking at its inverse. But that right there is the final answer. That's all we have to do for these here. Any questions on this first one here, how we found the inverse? Now, graphically, we can see that they are inverses. So the blue graph that I have posted up here is our y equals 6 to the x. Now, I included the red line because any inverse is reflected across the line y equals x. Its mirror image is going to be across it. Now, if I come back in here and turn this one back on and have it graph it, we'll see that these are exact mirror images across this line. They're reflected across it. So that tells us that y equals 6 to the x and y equals log base 6 of x are actually inverse functions. They undo each other. Because if we take the composite of those two, we'll get points along the line y equals x, that red line. Let's go on and look at the next one. Y equals ln x plus 3. Well, the first thing we can do is switch x and y. X equals ln of x plus 3. Y plus 3, thank you. Now, ln of x equals y if and only if e to the y is equal to x, is how we went about flipping it. So ln of x, what's inside x, is going to be on the outside. So here what's inside is y plus 3. So it will be on the outside. On the other side we have, and here, e to the y. Well, the y in this case is x. So if we switched it from logarithmic to exponential, we would go from x equals the natural log of y plus 3 to e to the x is equal to y plus 3. Questions on how do we change from the logarithmic to exponential? Now, we do need to get y by itself. Is y officially by itself? Well, no. So the last thing we need to do is minus 3 from both sides, which tells us that y is equal to e to the x minus 3. And that's it. That's all we need to do to find the inverse function. Questions on this here? What do we think of this so far? Not too bad? How do y'all feel about this swap between exponential and logarithmic? A little weird? Let me show you something. Y equals b to the x. And we've said, by definition, log base b of y is equal to x. If y equals b to the x, then we have this here. What we can do, and what we'll do, especially when we start solving, is I can take this and apply log base b to both sides of the function, which will tell me that I have log base b of y is equal to log base b of b to the x. Well, let me get a highlighter. Today, we went over what this is. If I simplified log base b of b to the x, what do we get? This here would be but we can't simplify log base b of y. So it's just log base b of y, and we have it equal to x, yes? But what did we say by definition b, y equals b to the x is as a logarithm? That's why we can switch it. Because we're essentially applying log base b to both sides to get this exponential to simplify out, to reduce. So we're just taking whatever that base is and applying it to both sides. And we get there. So really here, for this first one, I could have applied log base 6 to both sides. Log base 6 of x. The other side would simplify to just y. We would get to the same answer. Or we can do the other way. Here, I can apply e to both sides. Because if I apply e to both sides, well, e, ln's base e, those would cancel, giving us this. It's still the same thing. We're just using a trick for these last two. Here, we're using the steps. Does that make sense? Y'all kind of like these steps over the just magic, quote unquote, magically flip it from logarithmic to exponential based off some property. So let's use that with these here. So we'll use the properties instead of just the trick to flip from one to the other. Well, the first thing we'll need to do is rewrite this f of x as y. Now, because we're finding the inverse, we do need to switch x and y, which tells me x is equal to 11 to the y. And again, at this point, we're going to rewrite it as a logarithm. So if I'm going to apply a log to both sides, we're going to apply log base what? 11 to both sides. Because since we're wanting to get rid of the exponential, and the exponential has a base of 11, we're going to apply log base 11 to both sides. Because over here, log base 11 to the y is going to simplify to just y. On the other side, we're going to have log base 11 of x. Now, since y is by itself, we're done. That's the inverse function. That's it. And we'll be using this property and the one we're about to use here, especially when we start solving. It's going to make solving these a lot easier to work with. Any questions on A? Let's look at B. Now, B, they already wrote it as y equals, so we don't have to rewrite f of x. So the first thing we can do is switch x and y. X is equal to the natural log of y plus 6. So this time we were taking it from logarithmic to exponential. So we'll need to apply a base to both sides. And what base can we apply? E. Because e to the ln simplifies out, it becomes 1. And what that tells us is that we have e to the x is equal to y plus 6. Yes, because y is not by itself, so we do need to get it by itself by subtracting 6 from both sides, telling us y is equal to e to the x minus 6. And that's it. Questions on any of this here? So yes, even on the assignments where we talked about, I think it was trying to remember, I think it was 6.2 or 6.1. One of the previous ones where it's probably 6.3.1, where we're switching from logarithmic to exponential and exponential to logarithmic. We can use this property here to rewrite it to help us see how we switch from one to the other, because it still holds true. So last two here. So when we look at these two here, we first want to find the inverse of y equals 4 to the x. So the first thing we can do is switch it from y equals to x equals 4 to the y.
So it would be log base 4.
Yes. X equals y. So that is the final answer, and I'm going to write the in-between step because we could say log base 4 of x equals log base 4 of 4 to the y. And then that would simplify, giving us y equals log base 4 of x. And that is the final answer because y is by itself. If there was another value with y, we would need to simplify it out. So if we had 3y, we would have to divide by 3 or multiply by 1/3 to get y by itself. So that'd be first part. So we could switch x and y. X equals ln of y minus 5. And when we apply e to both sides, because that's where you're getting at, we would have e to the x equals y minus 5. Because here, e to the ln simplifies out. It simplifies to 1, leaving us with what's inside, which would be our y minus 5. Yes. Now, is y by itself? Well, no. So to get y by itself, we would have to add 5 to both sides, telling us y is equal to e to the x plus, and that's it. And this property here is what we're going to start using, especially when we start solving these. We're trying to solve exponential or logarithmic equations. We're going to be using this property to be able to get the variables by themselves and manipulate the equations. Any questions on any of this here? And that's it. That's all we're looking at today. This last part is really just to show us that the logarithmic and exponentials are inverses of each other because they're reflected across the line y equals x. Now your assignment is on page 319, 35 through 40, and 43 through 49 odd. Now looking ahead, tomorrow we're going to be covering 6.51, which is properties of logs. So we're going to be manipulating and using the properties of logs to rewrite or expand and condense logarithms and dealing with some common logs. Okay. Now, it works out that the assignment, quote unquote, assignment for tomorrow and Wednesday are the same thing. You'll notice when it pops up on the screen, they're the exact same thing. We're going through what we're going to do tomorrow twice, just so y'all get a good understanding of it. It's sometimes, some students find it confusing of what we're doing, but we're essentially just making it longer or making it shorter. Now, Thursday, I will not be here. So I won't be here Thursday or Friday. Now, I don't like having to do this, but I'm putting a video, already put the video together. It is up. It's in Google Classroom for you already, of what we're doing there. Now, the reason I'm doing that, having y'all watch a video and do the assignment, is because otherwise it would push 661 to Monday, which would make 662 Tuesday, which makes 663 Wednesday, 664 Thursday, which doesn't sound too bad, but that also means that next Friday's technically would be the makeup day, which means Monday the last week would be the review, which means Tuesday we would go over the review, and the test would be Wednesday.
And we graduate Thursday.
So that's, I feel is, it's too close to the end of the semester to do that and try to get y'all, make sure you get your test and everything done before the end of the term. So I'm doing that so that it gives you a few more days to finish the test up. So